All right, moving on. Let's take a look at application of linear functions. Problem 5 here. It says a trainer at Soul Fitness has a monthly salary of $1,690 if she offers 10 training sessions, and a monthly salary of $2,410 if she offers 30 training sessions. Find a linear function that models the data with the trainer's monthly salary, S, and is a function of the number of training sessions, X. All right, so we're going to model, right, the monthly salary for this trainer, all right, using X, our input variable, representing the number of training sessions, and the salary will give it the name of S. So it's a function of the number of training sessions depending on the salary she's going to get. So with that said, we're trying to find that function. So we want to find S of X, right? S of X equal to mx plus b, right? That's our linear function that we're trying to create. So again, remember S represents the salary and X represents training sessions. So I'll go ahead and make note of what everything stands for. Now, with that said, our first step 1, is to calculate the slope, right? We don't have the slope, we need to find the slope. So let's find the slope, m, right? So with that said, remember, m is your rise and your run, y2 minus y1 over x2 minus x1. So we need 2 data points. So let's find our 2 data points, and we'll go ahead and write those down. All right. And what are we given? So due data points, we have 10 training sessions. 10 training sessions, we'll write that down. All right, gave us a salary of $1,690. So there's 1 data point. So 10, number of training sessions, X. And the output, the salary, $1,690. So there's one of my data points. All right, so there's a point, again, XY. We can label that X1 and Y1 if you want. And then we also have, 30 training sessions. And with 30 training sessions, we had $2,410. So there's our second data point. So an X is 30, output is 2410. So there's X2 and Y2 if you want. So M, so again, plugging into our slope definition, Y2 minus Y1 over X2 minus X1 is equal to 2410 minus 1690. The Y values from those 2 data points divided by the change in X, which is 30 minus 10. All right, so as we simplify, let's go ahead and do the arithmetic together. So we can put 2410 minus 1690 in our calculator if we need to, and we get 720. And 30 minus 10, of course, is 20. And as we reduce, we got 72 over 2, or 36, right? So reducing down, here's M. So here's my slope. Right? So we found the slope. With that said, we can begin to write out our equation. So that implies y equal mx, 36x, plus b, right? So again, m equal 36. So now we got to find b. So that's step 2, right? Let's go calculate that b value. So that's our second step and our final step in creating out this linear model. So to do that, now I don't have b given to me directly. I'm going to use a data point. So again, I'm going to write down the point I'm going to use. I'm going to use 10 and 1690. Right? There's x and y. So again, pick a data point. We'll write that down over here and plug in. Plug into y equal mx plus b. So with that said, that implies we have y, which is 1690, equal to 36x, 36 times 10, plus B. So again, plugging in X and Y, and let's go ahead and simplify. So that implies 1690 equal to 360 plus B. And then we need to subtract that over. So 1690 minus 360 gives us 1330. So go ahead and move that over. And we can show our algebra here. So minus 360 on both sides. As we do that, again, we get 1330 there. So that implies B is equal to 1330. And that's our y-intercept value. So there's our B value, right, we're looking for. So as far as our function goes, so now we can write out our function. So that implies S of X, salary function, equal to M, 36X, plus B, 1330. There it is. There's our linear model. That describes the monthly salary for this trainer at Soul Fitness. All right. So let's move on to part B. Now we're going to use this model. It says determine a trainer's salary at Soul Fitness if she leads 21 sessions during 1 month. All right. Well, X is given, right? X equal 21 sessions. So again, with 21 sessions, right, they're giving us X. So that implies we need to find S of X, S of 21. So that would equal what? 36 times 21 plus 1330. And as we do the arithmetic, right, we get 756 plus 1330. And we add that, we get 2,086. So $2,086 would be their salary, right? And that would be our monthly salary if you did 21 sessions a month, right? Based off that slope, $36 per session. And then that adding to that the 1330 initial value that we had. All right, moving on, let's go to part C. So suppose the trainer needs her monthly salary before taxes to be at least $1,900. What is the minimum number of training sessions she can lead, right, for that to happen? So what's our equation here? So we're wanting to find out what? So this implies when does our salary equal 1,900? So that's our question at hand. So that implies, well, S of X is equal to 36X. So we're going to take our salary function, this linear function, and we're going to set it equal to 1,900, right? We want to know when we get a $1,900 salary. Let's find X. How many sessions does that need to be? So let's go ahead and solve it. So we're solving for X, right? We'll go ahead and move that 1330 over. So go ahead and subtract that, all right? And as we do that, all right, what do we end up with our equation? So we have 36X equal to 1,900 minus 1330. So again, plug in your calculator, double check, make sure your arithmetic is correct. 570. And our last step, we need to divide out the coefficient. So we'll divide out on both sides 36. And we'll have what we're looking for. We'll have X. So X is equal to 570 divided by 36. All right, so I've got, what, 15.8, right? 0.83 repeating. With that said, all right, if she needs to be at least $1,900, how many training sessions? So that implies a minimum of 16 sessions. There's the answer. So 16 of them. Last part is just to define our linear model, talk about what everything means in the function. So determine the meaning of slope in the context of this problem. Well, that slope is your rate of change. So our salary increases. So with that said, a trainer's monthly salary right? Increases by $36 per training session. Right? That's slope, the rate of change, right? $36. So again, remember M was 36, right? So again, that's $36 for every one training session. 36 over 1, right? Rise over run. Interpret the meaning of your y-intercept, your initial value. So this would represent the trainer's monthly base salary, right? So if X were equal to 0, we get our y-intercept. So without any training sessions involved, she's going to have $1,330 no matter what. So again, that's our base salary. So we can write that in there. So a trainer's monthly base salary. Right. With no training sessions involved, right? X equals 0. We're looking at our y-intercept value. There's your output. So again, just defining our variables, right? Again, our equation, our function. So slope, remember, is our rate of change, right? Y-intercept is our initial value, right? So again, with X equal to 0. So again, that gives us our base salary for this trainer. So again, that's a good little application of a linear model. So we'll take a break, maybe look at another one here in a little bit.